Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the largest perimeter triangle problem. Given an integer array nums, return the largest perimeter of a triangle with a non-zero area formed from 3 of these lengths. If it is impossible to form any triangle of a non-zero area, return 0. So they've given us the lengths 2, 1, 2. Obviously, if you add those up, you get a perimeter of 5. The trick is whether you can form such a triangle. The idea basically is you can form a triangle if the longest side you pick is less than or equal to the sum of the other two sides. So the longest side here is 2, which is less than 1 plus 2, which is 3. Here, 1 plus 2 plus 1, obviously if this was a perimeter, it would add to 4. The longest side, 2, is only equal to the sum of the other two sides. And if you kind of imagine how you could form a triangle with that, the idea would be effectively your long side is only just long enough to have the other two sides touching perfectly and sitting right on top of that long side, and obviously that has area 0. So that is 0. They don't, here both of the examples have length 3, but they don't actually make that, in fact they do not make that guarantee. They say there can be many. So what we want to do is we want to pick the largest 3 such that they satisfy the triangle inequality. And we maximize that. So we want to have the longest possible long side. And then the next 2... Well, no, yeah. Actually, how do we optimize that? Let me just think about this. So the reason I paused for a second is basically we want the longest possible long side. So if we had 2, 1, 2, 3, for example, we can't pick 2, 2, and 3 as our side lengths, because that's the 2 and the 2 are going to burst the 3, basically. But we can pick 1 and 2 to go with the... No, in fact, no, we do want to pick the 2 and the 2. The 1 and the 2 wouldn't make it, but the 2 and the 2 would make it. So if we pick the 3 largest sides, as long as the previous 2 sum to the greater than the third, then we're okay. If they do not, the longest side is too long, so we throw it away, basically, and then try again with the next 2 sides. With the next 3 sides, in fact. So basically, I'm thinking of a stack. The idea here is if we have 2, 1, 2, 3. Let's sort those. 1, 2, 2, 3. We're going to look at this and we're going to see the 3, the 2, and the 2. Those are the longest sides we have available. And therefore, those are the ones that are going to make up the triangle. But let's say instead we were given 2, 1, 2, and 5. Basically, this 5 is too big because any 2 other sides that we pick is going to fail. So first, again, we order them. And then we go, well, the 5, the 2, and the 2, those are our top 3. But 2 plus 2 is only 4. You could not make a triangle. So we pop the 5, and then we go again. 2, 2, 1. Can we make a triangle with those? Yes. We can, because we pick the largest and we see the next 2 down are 2 and 1. They're fine. So the largest area would be 3. Okay. And if we ever get down to, so if we did the 1, 2, 1 case, after sorting them, we have 1, 1, 2, we take the top 3, we see that doesn't work, so we take this off, it's now too short, so we return 0. Okay, simple enough algorithm. That was meant to be a let, and it turned into a leet. Whoops. We don't even need a let in Python. That's not a thing. Nums.sort. So now what we want to do is, I want to do while len nums is greater than or equal to 3. Come back to that, return 0. So what we want to do is A, B, C is equal to nums -3 onwards. If A plus B is greater than C, return A plus B plus C. Otherwise, nums.pop. So this is exactly the algorithm we were just saying. Sort them. So we get 1, 2, 2. Do they add up to, is 1 plus 2 greater than 2? Yes, it is. Great, return them. 1, 2, 1. So we turn that into a 1, 1, 2. We see 1, 1, 2. Is 1 plus 1 greater than 2? No, it's not. It's only equal. So we're going to pop. The array is now too short, so we return 0. If we had our, hang on, can't add test cases till I've run it. Cool, use the example test cases. So now if we had 1, let's call it 2, 5, 2, 1, that should fail. But if we had 3, 2, 1, 2, that should succeed. So looking at these test cases, remember we turn this into a 1, 2, 2, 5. And then look, see the 5 is too big, but then the 2, 2, and 1 work. Whereas here, we'd see the 3, 2, and 2 first, and we'd see that does work. So if we look here, we see we degenerate back to the 5, but in the other one we keep the 7, and that's exactly what they're expecting us to do. So the reason this degenerates to the 5 is because we cannot use the 5, so we're left with the 2, 2, 1. And here we can use the 3 and the 2, 2s, so that's why we get 7. All right, let's submit it. Perfect. I don't think there's going to be too much variation inside this particular problem. Basically, this is the solution for this particular problem. But it's a nice little one, nice easy one. If you're just getting into Leetcode, it requires a bit of thinking. You've got to think about how you do this vaguely efficiently. And a stack isn't immediately obvious here, because we're using our numbers list as a stack, because all I'm doing is popping from it. And peeking 3 times as well if we're sticking to the stack interface. Anyway, that's it from me for today. I do hope you enjoyed. Do remember to like, comment, subscribe, all of that good stuff. It really does help out the channel, and I really do appreciate it. Other than that, I will see you next time. Bye.